Hey YouTube, in this video we're going to discuss a basic property of radicals. We call radicals sometimes like radicals, and we treat this a lot like terms. Okay, so just really quickly here, I want to kind of review what we mean by like terms. But let's say I have some algebraic expression like 2x squared plus 4x minus 5 plus 10x squared minus 2x plus 1. The thing we could do is we could combine anything that had the same variable type to the same exponents, and we could just combine their coefficients. So like we'd say, well, it'd be 2 plus 10 of these x squared things plus now x to the first plus this x to the first. Here we say this would be really 4 minus 2 of these x to the first things. And then when you add your constants together, we say plus like negative 5 plus 1. So technically we're just combining coefficients. I mean, honestly, we get 12x squared plus 2x minus 4 is what we get in this case. But we're going to treat radicals much the same way. So for instance, if I were to say I had like 7 times the square root of 2, and I were to add like another 2 times the square root of 2. The thing here is this: we both have, on both of these terms here, we say like 7 times the square root of 2 plus 2 times the square root of 2. We could really just say this is 7 plus 2 of these square root of 2 things. So you can look at this right here. It's not a variable, it's a number, but they are like radicals. Okay, so we say like radicals. We could combine their coefficients, and this would just be 9 of these square root of 2 things. So essentially, let's start by defining this. We say like radicals. Two radical expressions are like radicals if they have the same index, the same indices. So these were both square root. Okay, they have to both be square root or both be the same root. And they have to have the same radicand. So in other words, you could say like, x square root of a plus y square root of a. If these are the same thing, you could say it's really just x plus y of these square root of a things. Okay, so we're going to do this to add or subtract radical expressions sometimes. You notice that this doesn't look like a radical expression right here. As a matter of fact, it says 7 times 6 to the 1/5 plus 2 times 6 to the 1/5, but I hope you recognize, first of all, that these are identical. So we could say, well, really, this is how many of these 6 to the 1/5 things? Well, I've got 9. I've got 9 of these 6 to the 1/5 things, and actually, you could leave it like that. But I will point this out. These are also roots. So we say this is really 7 times 6 to the first power fifth root. So we just say 7 times the fifth root of 6 plus 2 also times the fifth root of 6. We could say really this is 9 of these fifth roots of 6, which is really the same thing that we got written right here. So this one I just want to comment really quickly on. Right here we have the cube root of 16 minus the cube root of 2. And actually I want you to simplify this with like radicals, but you notice that these are not the same radicals. However, this can be simplified, this thing right here. And the reason why I say this is because, well, 16, this is not the prime factorization of 16. We say this is like what? 4 times 4, which is, 2 times itself 4 times. So we say the prime factorization is 2 to the 4th power. We'd say the cube root, we need to simplify this first. The cube root of 2 to the 4th minus the cube root of 2 to the 1st. And notice this, we say, well, I want to take out any perfect nth roots here. So I mean, if I were showing my work, I could say this is 2 cubed times 2 to the 1st minus, the cube root of 2 to the 1st power. But we could say that since I was able to make one group of 3 2's here, and I've got 4 total 2's, right? And I can make one group of this size. What we can do is we could cross that out. We could take one of those 2's out front. So one group of 3 2's escaped here, and we get left with this. We get 2 to the 1st times the cube root of, we had 1 2 left over on the inside, minus now the cube root of 2. This tends to throw people, but this has a coefficient of 1. So if I were to say, what's the 2 of these cube roots of 2, take away 1 of these cube roots of 2, we'd say, well, it's 2 minus 1, which is 1 of these cube roots of 2 would be left over. So sometimes you're going to need to simplify first, but that is the basic premise behind like radicals.